Hey guys, what's up? It's Mr. Handke. Here we are with 0.1. Just a quick review on points and functions. Alright, so we start off with a relation. A relation is just a set of ordered pairs. Okay, it's a set of ordered pairs. And then we're going to talk a little bit about domain and range. Domain are all the values that we use for our x-coordinates, and the range are all the values that we're going to use in our y-coordinate spot. Alright, so a quick example of domain and range. Alright, so here's my set, my relation, my set of ordered pairs. Negative 3, comma 1, negative 1, comma 5, 2, 7, 5, 10. Okay, so remember it goes x, comma y. X's are first, so I domain, and these are in order. It won't always be that way for you. It might be scrambled. Some people put them in numerical order. If you just want to go in order left to right, that's also fine with me. I think you're a lot less likely to make a mistake if you just go left to right as opposed to you try to put them in order. Sometimes you skip points. So my domain, my x's, we got negative 3, we're using negative 1, we're using 2, and we're using 5. Okay, some teachers get real picky about putting like set notation brackets around them. Okay, I know what you mean. I don't get all that worked up. If you want to put them, you can. If you don't, you don't. That's fine. Range, that's going to be the y values that we use. And again, these are go in order, so they're already going to be in numerical order. But sometimes they're going to be scrambled. If you want to rearrange them and put them in numerical order, that's great. You don't have to. You can just go left to right, whatever works for you. So we got 1 that we're using for a y value. 5, 7, and 10. If you want to put the fancy set notation brackets around them, you can. Okay, so that's domain and range. These are basically your x's. These are basically your y's. A function, all right, that is when each element of the domain is paired with only one element in the range. So each element of the domain, those are my x's, so each x is paired with only one element in the range. Those are my y's. So each x is only going with one y. So that's the translation there from math words to normal person words here, is that each x is only partnered up with one y. Okay? And it's kind of funny that we'll see why it works, that it doesn't matter about the y's going with more than one x, but each x can only go with one y. We'll get a visual representation of that on the back side of this sheet in a minute. But just remember that it only matters for the x's. Just check the x's first. Okay? So 1 goes with 5, 2 goes with 6, 3 with 7, and 1 goes with 10. So we have x. We have 1 going with 5, and we also have 1 going with 10. So we have one x value going to 2 different y values, and that is a no-no. That's what we're looking for. That is not a function. Okay? So kind of a cheater shortcut method for that is just quickly glance down your list. Do any of my x's repeat? Okay? Do any of my x's repeat? And then if they don't repeat, you should be in the clear. Okay, 1, 2, 3, 4. I don't have an x listed more than once, so it would be impossible for that number to be paired with something else. So this one we are in the clear. Function, right? 1 only goes with 5. I don't have another 1 later on. 2 is only going with 6. I don't have another 2 in there. 3 is only going with 7. Okay, you get the idea. All right. So for every rule like this, and then there's going to be an exception to it. This is kind of a tricky one. Okay, this is kind of a sneaky one. 1, 5, 2, 6, 3, 7, 1, 5. Quick scan down the x, 1, 2, 3, 1. Oh, I have x's repeating. I use 1 twice, but take a look. 1, 5, 1, 5. It's the same point. Tried to trick you. It's the same point. So 1 is going with 5. So it's not like it's going to two different numbers. It's still only partnered with 5. It's just written down twice. So you gotta be careful. That doesn't happen very often, but sometimes the book will try to be sneaky like that. So that is still a function, because that's the same point. Okay, that's the same point. So that's not breaking any rules. Okay, another big fancy math word. We got quadrants. Okay, think of where else you've heard the word quad before. Your muscle quad. I'm not sure if that's split into fourths. But a lot of times it's with, you hear four-wheelers called quads because they have 4 wheels. Okay, so quadrants split things. Quad, meaning 4, is going to split things into fourths. And we kind of count backwards here. It makes sense that this one is 1. That's our first one that we use the most. Positive x, positive y. That's quadrant 1. And then it goes counterclockwise. It goes opposite direction of what you would normally think of on like a clock or when you go in a circle. 1, 2, 3, 4. And I got kind of cut off a little bit by the copier here, didn't I? So negative 2, comma 4. It doesn't have to be exact with this. Just a quick little sketch just so you can get the idea of where things are. Negative 2, 4 is going to be over here in quadrant 2. 5, comma negative 2, 5, comma negative 2 is over here in quadrant 4, IV4. Okay, 3, 0. All right, it's on the line, so let's be descriptive about that. Be descriptive about that. It's on the x-axis between 1 and 4. Okay, so if you get one that's on the line, go ahead and tell me what line it's on. It's on the x-axis between 1 and 4. So be descriptive with that if it's on the line, if it's not in one of the quadrants. Okay? All right, we're going to have some visual. We got a couple more, I guess. Some more points. All right, so if you're watching this at home, go ahead and push pause right now on your own and kind of do these just like what we would have done on the front. Go ahead and push pause and give those a shot just like we did on the front. All right, unpausing. Here's what we got, our domain. And again, I don't care if you put them in numerical order or put them in just left, right. So we got 0, 7, negative 3, 1. 0, 7, negative 3, 1. My range, those are the y's, 5, negative 1, 2, 5. It is a function, yes. Okay, because each x only goes to one y. I know we got 2 y's listed, all right, but the one that matters is the x's. The x's don't repeat. Yes, each x only goes with one y. Okay, second one over here. We got 1, negative 7, so we got 1, 3, 1, negative 7, 3, 2. And this one, we got, boom, negative 1 with, or 1 with negative 7 and with 2. So that's not a function. We have an x value that has multiple y's, or more than one y. Okay, and some visual representations here, okay? Now we got a different way to think about domain and range, okay? We got a parabola. Its vertex, or the bottom point here is 4, negative 1. Okay, domain and range. Remember, domain are my x's. This is going forever, and it's pretty steep up, but guess what? It still gradually sliding out to forever. Forever this way, and forever that way. So when it goes on forever both ways, it's going to use all real numbers. So you can either write all real numbers, or you can give me like a fancy capital R. Sometimes it's got like a second little up branch there, or you can just give me a big old capital R. My range, what y values am I using? I'm going up forever. Right, it's going up forever. So we're going up forever, but we don't go down forever. What's the lowest y value I get? My lowest y value is -1. So it's all y values that are -1 and up. Okay? -1 and up. So how can I write that in math? Y's that are greater than or equal to -1. Alright, and when you have a visual, like a graph, here's a little shortcut for you. It's called the vertical line test. Alright, the pencil test, the finger test, vertical line test. If you can take a vertical line, or a pencil or your finger, and you can slide it through the whole thing and it never intersects more than one point on the graph, it's a function. Because that means my x's don't repeat, or that my x's don't have more than one y value. So yes, this is a function. X's don't repeat. And I'm okay with you saying passes vertical line test if it's a graph. Okay. Let's come back over here. Let's come over here to this other one. This is a sideways absolute value graph. Okay, look at this. All right, so we're definitely hitting more than once. We're going to hit twice in a lot of spots. Like right here is the only spot it would only hit once. Okay, it's going to hit twice here. So this x is going to have 2 spots. Boom, boom. This x is going to have 2 spots. Boom, boom. So this is not going to be a function, right? You'd have like 1, 1 and 1, like -3 or something like that. Okay, so that's not going to be a function. And again, on a graph, fails vertical line test, fails the v-line test. Multiple y values for one x, if you want to say that. Something like that. Okay, let's talk domain and range. So very similar to my range last time. Now it's my x's that don't go side to side forever. It goes forever this way. My x's don't go forever this way. So what's the furthest I get over here? -3, 2. So -3 is the furthest I get over here, and then the rest of my x's are this way. So my x's are greater than or equal to -3. They're all -3 or bigger. Okay, now my range this time, this one's going up forever, this one's going down forever, so my range is going to be all real numbers. And a lot of the times, at least something, one of these two is going to be all real numbers, if not both. A lot of the times it works out to be both. What's an example of a both one? Good question. All right, a regular line is a good example of both going off to all real numbers. Okay, goes up and down forever, gradually up and down forever. It also goes left and right forever, so that's going to be all real numbers both times. Another one is x cubed, something like this. Okay, gradually sliding out forever, and also going up and down forever. So there's another one that both would be all real numbers. All right, so there we have domain, range, and functions 0.1. All right, make sure you stop in or let me know if you have any questions. Enjoy.